Look up. The sky is dark, seemingly lifeless. But then, you notice something that wasn't there before. A bizarre, almost invisible light illuminates the previously black space. It's too late to run. You're both lucky and unlucky at the same time. You're witnessing the awakening of a giant, previously dormant black hole. Is it going to swallow both you and our world? Supermassive black holes, huge space objects millions of times heavier than our Sun, live in the middle of most galaxies. But they're really hard to see or study. Most of the time they sit quietly and don't do much for a long time. That's what was happening with a giant black hole in a faraway galaxy. This galaxy is 300 million light-years away from us, in a part of the sky called Virgo. For many years, the black hole there wasn't doing anything exciting. It was quiet and resting. But in late 2019, something strange happened. The galaxy suddenly got much brighter. It started flashing a powerful X-ray light. It was something scientists hadn't seen there before. This surprised astronomers, so they started watching it closely. After a few years of studying it, scientists have concluded that the black hole has likely woken up from its quiet state and become active. Now, the middle of the galaxy is really bright. It might mean the black hole is pulling in material and producing lots of energy. Astronomers even gave this black hole a fun nickname, Ansky. And the coolest thing about all this is that it's the first time we're watching a supermassive black hole switching to an active state in real time. Scientists at the European Southern Observatory in Germany were the first to notice something strange. They used special space telescopes, like NASA's Swift and another one called E-Rosetta, to look for X-rays coming from Ansky. At first they didn't see any. Then, in February 2024, another group of scientists noticed something new – bursts of X-ray light coming from Ansky. And these bursts weren't random. They happened almost like clockwork, at nearly regular times. This kind of flashing has a complicated name – quasi-periodic eruption, or QPE if you want to make it short. It's when a black hole suddenly flares up with a burst of energy, but only for a short time. And this is the first time anyone has seen a QPE in a black hole that was waking up after being quiet for so long. These kinds of events are also super rare. Scientists only found the first QPE in 2019, and they've only seen a few more since then. No one knows exactly why they happen, but watching Ansky might help scientists learn more about how black holes behave and grow. One important tool they used was the XMM Newton Space Telescope. It's the only one that can see the very faint background light between the flashes. By measuring how dim Ansky gets between bursts, scientists could figure out how much energy the black hole sends out during each flare. You might know that black holes have super strong gravity that pulls in anything that gets too close, even stars. If a star gets caught, it can be stretched and torn apart. The pieces of the star form a super-hot glowing ring that spins around the black hole. This ring is called an accretion disk. Scientists think that the quick flashes of X-rays, QPEs, might happen when something, like a star or even another small black hole, interacts with this spinning disk. QPEs have sometimes been linked to stars being destroyed. But with Ansky, there's no sign that it destroyed a star. So scientists started thinking of other reasons. Maybe the disk around Ansky is made from gas that the black hole grabbed from nearby space, not from a torn-up star. And maybe something small, like a planet or a star, is passing through this disk over and over again, shaking it up and making it flare with bright X-ray light each time. What makes Ansky really special is how big and powerful its bursts are. According to a student at MIT who worked on the study, Ansky's X-ray bursts last 10 times longer and are 10 times brighter than normal QPEs. Each burst gives off 100 times more energy than other ones scientists have seen. And the timing is strange too. Ansky has a pattern of flashing about every 4.5 days. It's the longest wait time between flashes ever seen. These strange features are making scientists rethink how QPEs happen and what causes them. Sadly, we don't have enough data yet to know for sure. Astronomers need to watch more of these events to figure it out. Now, you might be wondering how scientists even find black holes. After all, they capture everything, even light. Indeed, these space monsters are really hard to see. They're basically invisible. But scientists pay attention to what's happening around them. It can be glowing gas and dust somewhere in space. The thing is, black holes often have a spinning ring of gas and dust around them, called an accretion disk. This ring gets super hot and shines in X-rays and other kinds of light, which telescopes can spot. It can also be moving stars. Big black holes, like the one in the middle of our Milky Way galaxy, have such strong gravity that they make stars orbit around them. Scientists watch these stars move in special patterns and prove that there's a giant black hole hiding there. This discovery won a Nobel Prize in 2020. They're also on the lookout for ripples in space, because when giant objects like black holes move or crash into each other, they send out gravitational waves. Scientists have built special tools to feel these ripples and learn more about black holes. And finally, it's bending light. Black holes have so much gravity they can bend light from stars behind them, like a cosmic magnifying glass. This trick, called gravitational lensing, can help scientists find black holes that are hiding all by themselves. Now, you should keep in mind that, unlike some stereotypes, black holes are not wormholes, magic tunnels that take you to other places in space or different universes. Once you get into one, there's no way out or to the other side. Neither are black holes some kind of space vacuum cleaners. They don't go around swallowing everything they come close to. If you're far away, their gravity is just like that of any other object with the same mass. The black hole that's closest to us on Earth is called Gaia BH1. It's about 1,500 light-years away. As for the farthest black hole we know about, it's located in the middle of a faraway galaxy 13 billion light-years away. The largest black hole we've seen is called TON 618. It's 66 billion times heavier than the Sun. And the smallest black hole is just 3.8 times heavier than the Sun and sits next to a star. By the way, all black holes spin or turn really fast. The fastest one spins over 1,000 times every second. Plus, big black holes in the middle of galaxies can shoot out particles at super high speeds, almost as fast as light. If something falls into a black hole, spaghettification occurs. This object gets stretched out in space like a noodle because of the black hole's immensely strong gravity. And speaking of gravity, if our Sun were replaced with a black hole that had the same mass, Earth and the other planets would still orbit it in the same way. The gravity wouldn't change just because it's a black hole. Scientists have discovered two main kinds of black holes. The first are called stellar mass black holes, and they're usually about 5 to maybe 50 times heavier than our Sun. The second type is supermassive black holes, which are incredibly huge. Some of them 100,000 times to even billions of times heavier than the Sun. There might also be middle-sized black holes, kind of like the in-between type, but no one has found one for sure yet. Stellar mass black holes can form when two neutron stars smash into each other. Also, two smaller black holes can join together and make a bigger one. That's one way black holes grow. But supermassive black holes are still a big mystery. Scientists aren't exactly sure how the universe creates black holes that large.
A giant wormhole, or simply said, a connection between regions of space-time, opens up in space near Earth. Our world faces chaos unlike anything before. Satellites incinerated, skies ripped open by radiation storms, entire power grids blacked out. The atmosphere is swelling and scorching, the oceans are boiling, the magnetic shield is shattering. Suddenly, the wormhole destabilizes. Space-time starts to unravel, tearing Earth apart from the inside out. People are seeking shelter, but nothing can save them anymore. Look at this devastation. This isn't just a sci-fi scenario. It's a cosmic apocalypse waiting to happen and rewrite the fate of humanity. The thing is, some black holes might actually be secret space portals. It may sound like something straight out of Stranger Things, but it's not. Scientists have been wondering for years if some black holes could actually be wormholes in disguise, tunnels through space and time. And now, a new study says this might actually be possible, at least in theory. Wormholes are like cosmic shortcuts that let you pop out in a totally different part of the universe. Unfortunately, we've never found one, and the whole concept still lives in the land of what if. Here's the problem. To actually make a wormhole work, you'd need something called negative energy. That's not just rare. It doesn't even exist in the regular universe. Maybe in some weird world of quantum physics, but even there, it's super uncertain. Still, scientists have a wild thought. What if some black holes aren't just giant space vacuums that swallow everything around them, but are really hidden wormholes? The odds of that are tiny, like winning the lottery while getting struck by lightning and discovering extraterrestrials at the same time. But mathematically, it's not impossible. That's where the new study comes in. Researchers looked at a weird type of black hole called a Schwarzschild black hole. These ones don't spin, don't have electric charge, and, very predictably, are totally hypothetical. They're just the math version of a black hole, not something we've seen in space. In any case, the team studied something called quasi-normal modes, which is just a fancy way of saying how space vibrates around a black hole when you mess with it. These vibrations don't go on forever. They fade out like the ringing sound you get when you hit a bell. By analyzing those space-time vibes, scientists tried to figure out if they could tell the difference between a regular black hole and a wormhole pretending to be one. It turns out that it's super hard to tell this difference. But maybe that's the point. Wormholes might be hiding in plain sight, wearing black hole costumes like it's space Halloween. Wormholes could copy a black hole's behavior almost perfectly, at least on paper. The researchers uploaded the whole study to Arxiv, which is where science nerds drop their ideas before they hit the big journals. And it's already been published in Physical Review D, which is a serious physics magazine. The coolest thing, though, is that it isn't a brand new idea. Scientists have been debating this whole black hole or wormhole thing for decades. Back in 2021, some researchers wondered if the giant black holes at the centers of galaxies, called active galactic nuclei, were actually wormhole entrances. And in 2022, a team in Bulgaria said that the light coming from a wormhole could look almost exactly like what comes from a black hole. There's also this sci-fi level theory that some black holes might be paired with opposite twins, called white holes. A white hole basically spits stuff out instead of sucking it in. Together, a black and a white hole could form a wormhole tunnel. But no one's found a white hole either yet, so that idea is still just theory. By the way, in this latest study, the authors have shown that wormholes and black holes not only look similar, but also sound similar, at least in how space-time shakes around them when they get hit with something. So our next move should be fine-tuning our scientific models, especially near the part of the wormhole called the throat. Scientists want to see if wormholes could fake even more black hole-like behavior, but it's tricky. Some of the math gets super hard. In any case, how about finding out more about these mysterious wormholes? You've seen them in every second sci-fi movie, magical space tunnels that let you skip across the universe. Einstein was the first one to have dreamed them up. Wormholes are still 100% hypothetical, and we've never spotted one. But that doesn't stop people from theorizing. Like, what if a wormhole started sucking in matter like a black hole does? If a wormhole started eating stuff like dust, gas, or space debris, it would create a plasma tornado, a literal space firestorm in its throat. And this twisty storm would eventually blast out the other side of the wormhole, firing hot plasma at nearly 125 million miles per hour. That's about 1/5 the speed of light. It would also be insanely hot in there, so hot it could probably trigger nuclear fusion. Of course, all of this is still just theoretical. No one's seen a wormhole do this. No one's seen a wormhole do anything actually. But the math says it could happen, if we ever find a wormhole. The bright side of it all is that we would probably spot an event with so much drama. Even though wormholes don't have an event horizon, aka the point of no return, like black holes, they still bend light. Normally, you might not be able to see something like that, but this thing is so absurdly bright from the plasma firestorm that you would actually see it glowing in space. Think of it like a black hole, but with a glowing center instead of just darkness, and a jet of flaming plasma shooting out one side like a broken space faucet. Still, don't get your hopes up for spotting one anytime soon. Even if we did find a wormhole, it probably wouldn't last long. It could break apart or transform into a completely different type of space-time before we even realized what we were looking at. Plus, keep in mind that wormholes might look almost exactly like black holes unless you know what kind of light polarization, how light waves line up, to look for. Now let's talk a bit more about black holes themselves. You're likely to know them as insane space beasts that suck up everything nearby – gas, dust, even light. And once something crosses a black hole's event horizon, it's trapped forever. Scientists say that inside, everything gets crushed into a tiny point called a singularity, where the usual rules of physics totally break down. But back in 2010, a physicist named Nikodem Pavlovsky had a crazy idea. What if black holes don't have singularities? Instead, what if the center of a black hole is actually a doorway to another universe? Maybe our entire universe was born from matter shooting out of a black hole in some parent universe. Pavlovsky's theory uses something called torsion, which is like a weird gravitational twist that stops matter from getting crushed infinitely. Because of torsion, instead of crashing into a singularity, matter inside a black hole can create a tunnel, a so-called Einstein-Rosen bridge, or simply a wormhole, connecting a black hole to a white hole. So, imagine matter falling into a black hole in one universe, then popping out of a white hole in another. Pavlovsky thinks this could explain the Big Bang, but as a big bounce, meaning the universe keeps cycling through phases of expansion and contraction, not just one huge explosion. Sadly, if such a tunnel existed, it would be a one-way trip. Nothing would come back through to the original universe. Some scientists are still skeptical because torsion hasn't been proven yet, but other experts think Pavlovsky's model is super promising. They even go further and say that our whole universe might be living inside a giant black hole hundreds of billions of light years wide. Now, we just need to figure out how to test this. Future space studies might give us more clues, like checking if our universe is closed, which basically means that it's curved, without an edge, or digging deeper into cosmic background radiation, which is the leftover glow from the Big Bang. Scientists have thought for a long time that really huge black holes, those called supermassive black holes, sit in the middle of all big galaxies. But for some reason, try as they might, they couldn't find one in a galaxy called the Southern Pinwheel Galaxy, aka Messier 83, or M83, a spiral-shaped galaxy about 15 million light-years away from us. Still, researchers were sure it would be there. That was super confusing. And now, the super-powerful James Webb Space Telescope might have found a clue that there really is a supermassive black hole hiding in the middle of M83. Supermassive black holes eat up huge amounts of gas and dust, which makes them glow super bright. M83 didn't seem to shine, but could this glow be hidden by thick clouds of dust? Indeed, James Webb's amazing cameras have spotted clumps of special ionized gas that show up when a black hole is doing its thing, gobbling matter. So basically, the black hole could be playing hide-and-seek with us, and JWST might have just helped us figure out this long-standing mystery. So what exactly did scientists see? It was a glowing light coming from neon gas that needs a huge amount of energy, much more than what normal stars can make. This glow is a strong clue of a hidden active galactic nucleus. Even powerful star explosions, called supernovas, don't give off enough energy to make this kind of light. So, a supermassive black hole seems like the most likely reason. On the other hand, it's not the only possible reason. The glow might also come from shockwaves moving through the gas between stars, called the interstellar medium. To figure it out, scientists are going to take an even closer look using other powerful space tools like the Hubble Space Telescope, ALMA, and the Very Large Telescope. At the same time, this discovery shows how amazing the James Webb Space Telescope is. Apparently, it can find things in space that were safely hidden from our eyes before. Another example is an impossible black hole it helped to detect. On second thought, this discovery might not be as astonishing as it seemed at first. Let's figure out this mystery together. The thing is, astronomers thought they had found a super hungry black hole that was eating stuff 40 times faster than it should. And that was something that didn't make sense with the existing laws of physics. That black hole, called LID 568, was spotted with the help of the James Webb Space Telescope. It was from the early days of the universe, having formed just 1.5 billion years after the Big Bang. So, at first, it looked like the ravenous black hole was eating way too much and way too fast. That would have made it grow really big really quickly, which was surprising for such an early time in the universe. But now, after looking again with the Webb telescope, scientists realized they had been wrong all this time. The black hole hasn't been breaking the rules at all. What actually happened was that thick dust got in the way and made it look like it was eating more than it really was. Here's how black holes normally work. When stuff falls into them, it gets super hot and shines brightly. There's a rule called the Eddington limit, which tells us that the most a black hole can eat is based on how big it is. If a black hole tries to eat more, the light it gives off pushes the stuff away, so it can't eat anymore. Some black holes can eat a little more than this rule says. This is called super Eddington accretion, but not as much as 40 times. And the first guess said that LID 568 was doing just that, breaking this limit in a big way. And then, the new study, published in April 2025, showed that the black hole was actually eating at a normal rate. The mistake came from not seeing clearly because of all the dust in space. It blocks and scatters light, making it harder for us to see the black hole clearly. So in the end, our hungry friend turned out to be not so hungry and pretty normal. Kinda disappointing, right? Scientists say that if a black hole is hidden by dust, like LID 568, you have to fix the light measurements for the dust to get the right size for the black hole. If you don't do that, you might get the wrong number for how big the black hole is, which also messes up the calculation for the Eddington limit. In their study, the team measured the black hole size using infrared light. This light is not blocked by dust as much as regular light, which is what scientists usually use. Thanks to this, they found out that the black hole was almost 1 billion times bigger than the Sun, and about 40 times bigger than the old guess. With this new, bigger size, they could fix the calculation for the Eddington limit, which made it clear that the black hole wasn't as hungry and bizarre as they thought. So, its feeding habits don't mean it's a super huge black hole growing really fast. Scientists have known that dust can mess up measurements of black holes, but they haven't always been good at fixing it when studying galaxies far away. This means that other black holes might have also been measured incorrectly, and people might have misunderstood them. The team's new way of measuring could help scientists learn more about these black holes that are hidden by dust in galaxies, especially the little red dots galaxies discovered with the James Webb Space Telescope. When scientists look at the first pictures of those faraway parts of the universe, they found something totally new. A bunch of tiny, super red galaxies. They named them the little red dots. There are hundreds of them. These dots only show up during a short time in the universe's history, when the universe was about 1 billion years old. And these little red dots are super confusing. They kind of look like two totally different things. Really heavy galaxies packed with stars, or modestly sized galaxies with a supermassive black hole in the middle. But one thing is clear. The typical red dot galaxy is tiny, only about 2% the size of our home Milky Way galaxy, and some are even smaller. So, what makes them shine? There are two main ideas. One of them claims that each little red dot is filled with a crazy number of stars, up to 100 billion, which is about the same number of stars as the Milky Way, even though a red dot is way smaller. Imagine standing in a huge, quiet room. That's like space near our solar system. Now imagine that same room completely jam-packed with the whole population of a very large country. Super crowded. That's what the inside of a little red dot might be like. It could be one of the most crowded places in the universe. Scientists aren't even sure galaxies this packed can really exist. Another idea is that these red dots are small galaxies with a giant black hole in the center. Scientists can spot signs of black holes by looking at how gas swirls around them. It gives off a special kind of light. And in many little red dots, they've seen those signs. Now, here's the strange part. The black holes seem way too big for such tiny galaxies. Usually, a black hole is only a tiny part of a galaxy's weight, about 0.1%. But in some of these dots, the black hole might be almost as heavy as the whole galaxy. That's really unusual, so scientists call those monsters supermassive black holes. And there's one more mystery. Normal black holes give off X-rays, and these ones don't. Even when scientists use special telescopes to look for X-rays, they couldn't find any. It's like these black holes are playing hide and seek, and we don't have the necessary means to find them yet. You're traveling through space, trying to get through an especially rough patch. You gotta dodge asteroids, space debris, wandering black holes. Now, it's not an episode of a sci-fi series, at least not completely. For the first time ever, astronomers have found a black hole that's completely alone, drifting through space with no stars or planets nearby. This black hole is about 5,000 light-years away from us in our own Milky Way galaxy. Do we need to look for a hero with superpowers to save Earth? First things first, a black hole is a place in space where gravity pulls so much that nothing, not even light, can get out of this region. The gravity is so strong there because a huge amount of matter is squeezed into a tiny space. Supermassive black holes, hundreds of thousands to billions of times the mass of our Sun, are often found at the centers of galaxies. Most of them stay put or move at a very, very slow pace. But the newly discovered black hole is much weirder than anything we've seen before. First of all, it tries to avoid commitment. It's lonely, with no companion star or home galaxy. An even stranger thing is that it's zooming through space at a speed of 31 miles per second. What might be the reason for this speedy cosmic journey? Let's look at the following imaginary scenario. One day, a really massive star exploded in a supernova. It was the very star that formed our black hole. The resulting blast gave the new black hole a massive kick and sent it flying through the galaxy, starting its unbelievable voyage. Now, it's only one of a few possible explanations, but it sounds quite plausible. I bet you can't help but think, what if this wandering black hole decides to visit our solar system? Are we doomed? Scientists tell you to relax and breathe out. This black hole is very far away, and your chances of ever encountering it are infinitesimal, if any. Plus, this black hole is totally quiet and dark at the moment. One day, it might wake up and start glowing. It'll happen if it begins to eat something. In the near future, powerful new telescopes may find many more wandering black holes like this one. Usually, black holes are super hard to find because they don't give off any light. You can only detect them when they're eating nearby matter. That makes them glow brightly. Or when they have a companion star. In this case, it moves in a strange way, which gives away the presence of a black hole. But this newly discovered black hole is lonely, totally by itself. There's no glowing, no companion star moving hectically. So, how did scientists spot our cosmic wanderer? They used something called gravitational microlensing. That's when the black hole's gravity bends and magnifies the light from a star located behind it, kind of like using a magnifying glass, hence the name. This method allowed scientists to detect the black hole even though it was completely dark. All in all, black holes are fascinating things, and some of them are truly unique, like these biggest black holes ever found. You see, almost every galaxy has a supermassive black hole at its center. They're huge, with masses millions to billions of times bigger than our Sun. One of those is called TON 618. It's a really huge and powerful black hole that's part of something called a quasar, a super bright spot in space emitting incredible amounts of energy. TON 618 is very, very far away, about 18.2 billion light-years from Earth. And it's 40 billion times heavier than our Sun. There are also black holes that feed on their own kind. Black holes are known for devouring anything that gets too close. And this anything can include not only stars and gas, but also other black holes. Scientists witnessed a ginormous black hole at the heart of one galaxy being swallowed by an even larger black hole in another galaxy. It was the first time we detected such an event. The discovery was made using NASA's Chandra X-ray Observatory. One black hole weighs about 30 million times the mass of the Sun, while the other has at least 1 million times the mass of the Sun. Then, there is a bullet-shooting black hole. Apparently, black holes don't just swallow matter, they can also shoot it out. For example, astronomers studied one relatively small black hole, which is about 28,000 light-years from Earth and weighs between 5 to 10 times the mass of the Sun. And they saw how this black hole pulled matter off a companion star and then blasted some of it out in the form of huge bullets of gas. These bullets are super fast. They move at nearly a quarter the speed of light. Some black holes spin incredibly fast, twisting space around them at extreme speeds. One example is a black hole located in the constellation Agila, about 35,000 light-years from Earth. This black hole spins at a staggering speed of more than 950 times per second. If you could place an object on the edge of this black hole's event horizon, it would spin around the black hole at 333 million miles per hour. That's nearly half the speed of light. The smallest black hole discovered so far has been nicknamed the Unicorn. Located 1,500 light-years away from Earth, it's around 3 times the mass of our Sun. This makes it very close to the smallest possible size for a stable black hole. While black holes themselves are far away and difficult to study directly, scientists find new clever ways to study their properties right here on Earth. They've been able to recreate certain features of black holes in the lab. For example, black holes have a gravitational pull so strong that nothing, including light, can escape once it crosses the event horizon. To understand this better, researchers have created an artificial event horizon using fiber optics. They've also been able to simulate Hawking radiation, the kind that likely escapes black holes, by setting up experiments in the lab. These lab-created mini black holes help scientists understand the mysterious properties of real black holes. There are several types of black holes, and each of them is born in its own unique way. Primordial black holes are believed to have formed right after the Big Bang, when the universe was very young. Stellar black holes form when a massive star collapses in on itself. This causes a supernova, where the outer layers of the star explode into space and the core turns into a black hole. As for supermassive black holes, they're thought to have formed alongside the galaxies they're in. The size of the black hole is usually related to the size and mass of the galaxy. Despite what many believe, black holes don't roam the universe randomly, looking to swallow planets. They obey gravity like anything else in space. So, for a black hole to affect Earth, it would have to be very close, much closer than any black hole is to us right now. Even if a black hole the same mass as the Sun replaced our Sun, Earth wouldn't fall into it. The black hole would still have the same gravity as the Sun, and Earth would continue orbiting it just like it orbits the Sun today. It would get much colder though, so we wouldn't survive such a replacement in any case. But don't worry, our Sun will never turn into a black hole. It doesn't have enough mass to do so. Instead, in about 5 billion years, when the Sun reaches the end of its life, it will become a red giant star. After using up its fuel, it will shed its outer layers, creating a glowing ring of gas called a planetary nebula. What's left will be a cooling white dwarf star.
Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called gravastars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball like a bowling ball onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball like a marble across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But gravastars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of gravastars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravastars were dreamed up by two physics professors, Paul Mazur and Emil Mottola, in 2006. They tried to think what else besides black holes could happen when a massive star collapses on itself. That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a gravistar, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that gravastars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller gravistar inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of gravastars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single gravistar might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a gravistar, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a gravistar. Of course, these are all just speculations for now. But where are all those gravastars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in space-time, hasn't found clear evidence of gravastars. Another problem is that gravastars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach gravastars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But gravastars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that gravastars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity. NASA has recently revealed some eerie cosmic sounds that go against the popular misconception about the muteness of space. This discovery proves once again that the universe is far from silent. The revelation came from the Perseus galaxy cluster, located 250 million light-years away from Earth. There, NASA uncovered an unworldly howling coming from the supermassive black hole at its center. This discovery isn't super fresh. It was made in 2003. It marked the first time scientists detected an acoustic phenomenon from such a distant source. Sadly, the sound was not something you would be able to hear. Its frequency was just too low for the human ear to register. The lowest pitch the human ear can perceive is 20 Hz, 20 cycles per second. But the sound emitted by the black hole is a B-flat, 57 octaves below middle C, with a frequency of 10 million years. But NASA brought it to the realm of human hearing in 2022, turning that invisible sound into something you could actually experience. It was a breakthrough of cosmic proportions when NASA revealed that sound waves could travel through space, specifically through the medium of the Perseus galaxy cluster. This medium is a hot, dense gas, something far more substantial than the empty vacuum between galaxies. That's how sound waves manage to travel there. Those sound waves produced by the supermassive black hole at the center of Perseus resonate through the hot gas as ripples. It's like how sound travels through water here on Earth. The thing is, space is indeed a vacuum, which means that sound cannot travel through it, in the traditional sense. But the gas surrounding the black hole in Perseus provided the perfect environment for sound to travel. The black hole's powerful jets create ripples, sending vibrations through the gas. And NASA scientists have identified those vibrations as a type of cosmic sound. Previously, it was totally invisible and unhearable. But now, for the first time, astronomers have helped it to take a form humans can hear. To give us a sense of how deep this sound is, NASA raised its pitch by 57 octaves so that it could finally be audible to the human ear. The result is a haunting, bass-heavy hum. It feels as though it is resonating from the very core of space itself. What NASA did is called sonification. This process involves mapping the characteristics of the data to audible sound. As a result, we can experience something that is otherwise beyond our perception. See those brighter areas of the cluster? They produce louder and higher-pitched tones. The sonification of the Perseus black hole isn't just a scientific discovery. It has allowed us to see, or should I say, hear, the universe in a completely different way. NASA has used this technique on several different space objects, including stars, nebulae, and galaxies, giving us a glimpse into the various ways space can sound. One of the coolest NASA's sonifications is Cassiopeia A. It's the remains of a star spotted as a supernova more than 300 years ago. Located around 10,000 light-years away from Earth, this shattered remnant of a once massive star has a neutron star at its core. And it's the youngest neutron star in our galaxy that we know about. To perform the sonification of Cassiopeia A, NASA took the data captured by the Chandra X-ray Observatory and translated it into sound. Starting at the center, a triangle-shaped tone marks the location of the neutron star. Then, the sound spreads outward, which represents the expanding debris field. That's when the pitch rises and the tones become brighter. The sound grows louder and seems to mirror the outbursts of the supernova and the formation of new elements. The Tarantula Nebula, located in the Large Magellanic Cloud, is a hotbed of star formation and one of the most active regions in the universe. Astronomers have been studying this nebula for a long time to learn more about how stars are born and evolve. So, no wonder that NASA scientists have been doing their best to translate the data from the nebula into sound. They've been mapping brightness and pitch to various features in the nebula. So, airy, synthesizer-like tones represent the chaotic and hot gases surrounding the most massive stars. And the cooler gases that are forming new stars have soft, low notes. Piano-like tones correspond to the brightest stars. And the central cluster of stars sounds like a rain stick. Interestingly, NASA's investigation into the sounds of space doesn't just involve cosmic phenomena. It's also based on the experiences of astronauts, and some of them are truly eerie. After all, space exploration is always filled with unexpected surprises, and sometimes those surprises come in the form of strange noises aboard spacecraft. One such incident occurred aboard the International Space Station, when astronaut Butch Wilmore reported hearing a strange noise coming from Boeing's Starliner spacecraft. By that time, this spaceship had been docked at the station for almost 3 months. The Starliner had just completed an 8-day mission that went awry. The technical issues have been plaguing the spacecraft ever since. Wilmore described the sound as a pulsing noise, similar to a sonar ping. It was coming through the spacecraft's speaker system. This strange noise made Wilmore contact NASA's Johnson Space Center in Houston. Of course, Mission Control immediately began investigating. They were able to listen to the audio inside the Starliner. Wilmore even held his microphone up to the speaker so that NASA could hear it more clearly. The people in charge of the investigation finally identified the source of the noise. They announced there was an audio configuration issue with the ISS's complex communication system. The thing is, this system connects numerous spacecraft and modules, and such configurations can sometimes lead to strange noises. NASA reassured everyone that such an issue wasn't really unusual. At the same time, they encourage astronauts to report any unexpected sounds they come across. At the same time, this incident was just another proof of how tricky it is to maintain advanced spacecraft systems in orbit. The Starliner had already faced serious delays and setbacks, and every new issue added extra pressure. Everyone was worried about the spacecraft's safe return to Earth. In any case, it's not the only incident involving eerie space sounds. In 1969, during the Apollo 10 mission, astronauts heard something truly bizarre while orbiting the Moon. Now, Apollo 10 was a dry run for the historic Apollo 11 moon landing. This mission involved astronauts Thomas Stafford, John Young, and Eugene Cernan. They were testing the systems of the lunar module. Everything was going smoothly, and then they started passing behind the Moon. In that region, radio signals from Earth couldn't reach them. At that point, they all started hearing a strange, high-pitched whistling sound. It was coming through their headsets. The origin of this noise baffled the astronauts since it wasn't supposed to exist in the near vacuum of space. At first, they simply joked that it sounded like outer space music. But in reality, the situation was quite unnerving. The astronauts were on the dark side of the moon, far away from Earth and any help. And now there was also that eerie, mysterious sound they couldn't explain. At the same time, NASA was super worried about astronauts' health and mental condition. So the crew didn't immediately report the noise to Mission Control. But after they returned to Earth, NASA engineers thoroughly investigated the phenomenon. They came to the conclusion that the sound had most likely come from the spacecraft's communications system. The reason could be the unusual circumstances of the mission. After all, the spacecraft was kinda cut off Earth. The moon was between it and our planet. Still, even after this extensive analysis, the origin and nature of the whistle is still a great mystery for many people. Anyway, all these new discoveries and old cosmic puzzles prove that the universe is far from silent. It hums, roars, whispers, and reveals the mysteries of the cosmos one note at a time. In the future, as our technological abilities continue to evolve, NASA's work with sonification and its study of strange astronaut experiences will likely lead to even more awesome discoveries. And if we listen more closely, we may find that the universe is much more talkative than we think. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists from the European Southern Observatory's Gaia mission spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest black hole to our planet ever discovered. The nearest one is called Gaia BH1. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of about 9.6 times that of the Sun. It means that it's way smaller than the newly found black hole. Gaia BH3 is located in the Agila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Okay, we can probably admit that this stellar black hole is just a small fry compared to supermassive black holes like the one that dominates the center of the Milky Way. I'm talking about Sagittarius A star. This space giant has a mass of 4.2 million times that of the Sun. While a stellar black hole forms when a star collapses, supermassive black giants have their own ways of seeing the light of day. They are usually the result of mergers of progressively larger and larger black holes. We'll talk about that later. First, let's speak a bit more about how stellar black holes form. When stars near the end of their lives, they typically inflate, lose a lot of mass, and cool to form what we know as white dwarfs. Such massive stellar black holes as Gaia BH3 are believed to form when a star doesn't contain heavy elements and loses not so much mass over its lifetime. Such stars are called metal poor. Afterward, instead of cooling into a white dwarf, this star collapses into a black hole. The companion of Gaia BH3 is a very metal poor star. It suggests that the star that collapsed and formed BH3 was metal poor too. Astronomers know of about 50 stellar black holes in the Milky Way. Some black holes are larger than others. You see, the universe is filled with black holes. Some of them are sprinkled randomly throughout galaxies. Others, those giants we know as supermassive black holes, sit at the center of galaxies. While stellar black holes are usually just a few times bigger than the Sun, such space monsters can weigh from 1 million to 1
billion solar masses. But even though they're so much heavier than our star, they're packed into a relatively small area. On a cosmic scale, of course, the size of our solar system or so. Some astronomers think supermassive black holes could form by several stars colliding and collapsing at once, while other experts state that such space objects might have started growing several billion years ago. At first, a small seed appears somewhere out there in space, which then gradually increases in mass to form a black hole. This seed does it through the process of accretion, which basically means gathering more and more matter around itself. Besides the absence of any precise information about the formation of black holes, there's also the black hole information paradox. If a black hole has some mass, and as we know, these spaced objects have a lot of it, then, according to the first law of thermodynamics, it should have a temperature. And according to the second law of thermodynamics, it should also radiate heat. Stephen Hawking showed that black holes are supposed to emit radiation too. These days, this kind of radiation is called Hawking radiation. It should form at the boundary of a black hole, but after proving it, Hawking pointed out a paradox. If a black hole is capable of evaporating, some of the information it contains can be lost forever. The problem is that the information contained in thermal radiation emitted by a black hole gets degraded. It doesn't repeat any information about the matter swallowed by a black hole before. Such an irreversible loss of information contradicts one of the basic principles of quantum mechanics. Physical systems that change over time cannot create or destroy information. It means we must be missing something. Both physicists and mathematicians have tried to come up with different ideas, but they ended with pretty weird results. Some have even claimed that the universe could be holographic. It means that the universe that we know and love is actually the result of some mysterious interactions at the infinitely distant boundary. I told you, black holes are really strange. At the same time, we have definitely found space objects that seem to have the properties of black holes. For example, look at this image of black hole M87 star. It certainly looks like a physical object, but what if black holes don't exist at all? There's an idea that black holes are actually gravastars, a blend of gravity, vacuum, and stars. This theory was first proposed in 2001 by Emil Matola and Pavel O. Mazur. They hypothesized that at one point during the collapse of a large star, intense gravity might transform its matter into a new state. It's similar to what occurs when atoms are cooled to such low energy states that they start acting like a single superatom. When we speak of gravastars, a star might collapse to the point of the event horizon, or the point of no return, and then its matter is transformed into a new state. It exerts enough outward pressure to prevent the star from collapsing into a physics-defying singularity. In gravastars, an ultra-thin, ultra-cold, and ultra-dark indestructible shell surrounds heavily wrapped space-time. This new form of matter turns out to be very durable, but it's also a bit flexible, like a bubble. So anything that's trapped by the intense gravity of a gravistar and smashed into it gets obliterated and then assimilated into the shell of this bizarre space structure. One of the benefits of the gravistar theory is getting away with those messy paradoxes connected with information and singularities. But even though this idea sounds kinda cool, it doesn't explain the phenomena we observe. And we've definitely observed something that looks like black holes. On the other hand, look at this shadow. It isn't caused by the trapping of light in the event horizon. It's a slightly different phenomenon known as the gravitational redshift. It makes light lose energy when it moves through a region with a powerful gravitational field. So, potentially, it could be a gravistar. When the light emitted from the regions close to the alternative objects reaches our telescopes, most of its energy is already lost to the gravitational field, which causes the appearance of this shadow. And still, like with black holes, things get complicated when you add rotation to the equation. Many experts are sure that gravastars would not be able to remain stable during rotation. But wait, it gets even more bizarre. There are suggestions that the insides of gravastars could contain a series of thicker shells. Those are known as nestars, something like a matryoshka doll. Of course, these theories aren't perfect yet. Astronomers still have a lot of work trying to build functioning models. There's also a chance that both black holes and gravastars exist. But then, we've got another problem on our hands. How can we distinguish between the two? Some theories suggest that these different kinds of space objects should also emit very different gravitational radiation. It could allow us to figure out whether we're looking at a gravastar or a traditional black hole.
Black holes, an enigma that has puzzled scientists and captivated our imagination for decades. But what's hiding inside of a black hole? Is it a void? A bottomless pit? A parallel universe? We don't know for sure yet, but scientists might have some ideas. So let's hear them out. Picture this. In the vastness of space, there's a supermassive star, shining bright like a diamond. But like all good things, this star's party can't last forever. Eventually, it runs out of fuel and goes out with a bang. Quite literally, the star collapses under its own gravity, creating an implosion. Now, this collapse is so intense that it creates a bottomless pit in space, like a sinkhole. This is what we call a black hole, the ultimate no-escape zone, sucking up everything in its vicinity, including light. Imagine yourself approaching a black hole. The black hole itself doesn't emit any light, but you can notice a dazzling display of cosmic fireworks surrounding it, the accretion disk. It's like a celestial carousel of gas and dust swirling in a mesmerizing dance around the black hole. The incredible gravitational forces pull all this material from their surroundings, creating this celestial furnace. Of course, it's very unlikely that you would have survived in this place. Temperatures here soar to millions of degrees. Also, it's constantly dazzling X-rays and high-energy radiation that can be detected from telescopes on Earth. But let's imagine that you did survive, somehow. As you get closer, you notice a mysterious boundary looming ahead, the event horizon. It's a point of no return, beyond which the laws of physics seem to go haywire. Now you're stuck in a space traffic jam, and no matter how hard you hit the gas, you're going nowhere. Once you cross this threshold, not even light can escape. And now, you inevitably fall into a black hole. What do you see around you? According to the genius physicist Albert Einstein, space and time aren't separate entities, but rather intertwined in a fabric called space-time. It's like a cosmic trampoline that can stretch and bend if you place something heavy on it. And black holes are super heavy, which is why they distort this trampoline in the most extreme way possible. So when you venture close to a black hole, you're in for a roller coaster ride. The curvature of space-time becomes so intense that it's like a whirlpool pulling everything in, even light itself. Everything around you looks like a space funhouse with distorted colors and rays of light that keep shifting. All this makes you feel like you're doing the moonwalk on a treadmill. Also, the curvature of space-time around a black hole is so extreme that it creates a phenomenon called time dilation. Time near a black hole moves at a different pace than in the rest of the universe. The closer you are to the black hole, the slower time ticks, like a slow motion effect. And the deeper you fall, the weirder things get. The laws of physics seem to break down before your very eyes. But suppose you somehow manage to survive all this madness. Where exactly are you falling? What awaits you on the other side? Is there even an other side? As you venture deeper into the celestial maelstrom, you reach an elusive and mysterious point called the singularity. It's the heart of a black hole, a place where all matter and energy are crushed into a single, unimaginably dense point. Imagine cramming masses of entire stars to something that is essentially a pinprick. And now that you're here, forget about the usual rules of physics. Welcome to a new realm, where the known breaks down and the unknown takes over. So, what does this unknown look like? Well, there are a couple of theories. First off, it could be a gateway to other dimensions. What if there are multiple universes hiding within black holes, like nesting dolls? According to this theory, the interior of a black hole could be a portal to a parallel universe with its own set of physical laws and possibilities. This parallel universe could be drastically different from our own world. What a mind-bending idea! Or what about wormholes? Imagine black holes forming a space subway system, connecting different regions of space and time with each other. These theories suggest that the extreme gravitational pull of a black hole could create a wormhole, a tunnel that could transport you to another galaxy, or even to the past or future. It's like finding a secret passage in a video game. That's not all. Some scientists propose that inside a black hole, we might find some exotic matter, some strange matter with weird properties or negative energy density. If that's the case, this would defy our understanding of the universe. And finally, one of the most mind-bending theories is that a black hole could actually lead to a white hole. Imagine, as you fall further, you suddenly find yourself in a blindingly bright space show. You're in a white hole. This is a fountain that's spewing out matter, energy, and information into the universe with reckless abandon. The birthplace of new universes. You see, while black holes are known for their event horizon, white holes have an anti-event horizon. With black holes, everything can enter and nothing can come out. With white holes, it's the other way around. They repel everything. White holes are hypothetical objects. Their existence hasn't yet been proven. But if it turns out that they exist, they could be connected to black holes. It makes sense. Black holes suck everything in, and white holes should take their matter from somewhere. And all this matter and energy coming out of the white hole could potentially form new universes. Together with black holes, they could form a universal cycle of creation. The end of one universe leads to the birth of another. All these theories are beautiful and fascinating, but here's the catch. There's still no concrete evidence of any of them. Black holes still remain one of the biggest mysteries of our world. Unfortunately, studying these mysterious beasts isn't easy. They're super elusive, and this is one of the biggest challenges for scientists. Black holes don't emit light, so they can't be seen directly. They're essentially invisible to telescopes that rely on light, making them incredibly difficult to observe. That's why scientists have to rely on things like X-ray emissions, the effects of a black hole's gravity on nearby objects, and other clues. They're also very unpredictable. For black holes, physics is like a fun playground. They warp space and time around them, which makes it difficult to predict and understand their behavior. But don't worry, space enthusiasts. The future of research in this field is as promising as ever. We've already made incredible discoveries. For example, in 2019, we captured the first ever direct image of a black hole. This is a central black hole of the galaxy Messier 87. A few years later, we also took a photo of a black hole in the center of our own galaxy, the Milky Way. This one is called Sagittarius A star. All this has opened up new avenues for research. And these aren't the only cool things we've discovered in recent years. Let's take gravitational waves, for example. You know how rocks leave ripples after falling into water? Well, gravitational waves are ripples in the fabric of space-time. They carry clues about the most cataclysmic events in the universe. They've allowed us to listen to the universe, unveiling previously hidden phenomena and events. And all these observations provide us with a new way to study black holes. We constantly make new advancements in technology. The James Webb Space Telescope will provide us with even more detailed observations and insights into the mysteries of black holes. There's still so much we don't know, but that's the beauty of science, the thrill of the unknown, and the curiosity that drives us to explore the mysteries of the universe. So, let's keep peering into the cosmic abyss on the thrilling quest to unlock the secrets of our world.
Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So, let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here. Imagine a black hole, a terrifyingly dense space object pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine 2 of these space monsters colliding. Scary? You bet. Astronomers have spotted 2 supermassive black holes feasting on the cosmic material of 2 merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than that of our Sun's. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noted that two gigantic black holes were growing alongside of each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. Now, we can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we're talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other. And eventually, they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought, too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several hundred million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists, consisting of more than 200 astronomers, had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they're really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we're not going to be pulled into this hole. It's more than 26,000 light-years away from Earth, and that's too far for this monster to have any influence on our planet. Besides Sagittarius A star, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? Nah, you do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops, bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Well, typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A star, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you managed to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes, located in different galaxies, aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement.